In today's class, we are going to discuss about the basics of hypothesis testing. In this class, I am going to discuss about what is a null hypothesis and what is an alternate hypothesis, and what are the various criteria of setting an hypothesis, that is, what is the level of significance, what is the p-value, and what are the various parameters which are helpful in the testing of the hypothesis, or especially the testing of the null hypothesis. So in this class, we are going to first discuss about the null hypothesis, level of significance, power of a test, p-value, and the statistical estimation of the confidence interval. In the coming classes, it is the basics of the testing of hypothesis, like how the an hypothesis, null hypothesis, can be tested by using the student t-test, chi-square test, and analysis of variance. Before learning that, we should learn the basics of an hypothesis testing, that is, what is the null hypothesis, level of significance, power of a test, p-value, and the confidence intervals. So, an hypothesis is a claim we want to test, and an hypothesis testing is the process of interfering, or is the process of inferring from a sample whether to accept the claim, that is the hypothesis, or whether to reject the hypothesis. Okay, so hypothesis testing is the process of testing the hypothesis, that is, it is the process of testing our claim. We perform the hypothesis test in order to either accept a particular claim or a certain statement regarding a population or a group of samples. And in this case, the sample is assumed to be a small representative of a proportion of a total population. Okay, sample is a small representative of a proportion of a total population. Okay, we are performing hypothesis test in order to accept or reject a claim, okay, about this small representative of a population, that is a sample. Okay, using an inferential statistics, there are two possible outcomes. I mean, there are two possible hypotheses. Those are a null hypothesis and a research hypothesis or alternate hypothesis. Null hypothesis is represented by H0, and an alternate hypothesis can be represented as HA. So, what is null hypothesis? A null hypothesis is often set up. Okay, it is the most commonly set hypothesis in the statistics. Okay, in practice, the hypothesis most often set up is the null hypothesis, okay, which assumes there is no difference between the two populations that is being sampled. Okay, so according to null hypothesis, we can assume that there is no difference between the two populations which are being studied. However, even in such conditions, although if we assumes there is a difference between the there is no difference between the two populations or two groups, there exists a small difference, okay, maybe due to the chance variation. Okay, even in such conditions, the sample means are most unlikely to be identical, since there will be some difference between them due to chance variation. and we set limits with this kind of chance variations. Okay, we set particular limits within which we shall regard the samples as not having any significant difference. Okay, in order to say that really there is a difference or no difference, or to minimize this chance variation, or even for this chance variation we'll set a particular limits so that an hypothesis can be effectively tested. That means a null hypothesis can be effectively tested when we set particular limits for this kind of chance variations. And coming to the level of significance, before discussing the level of significance, let us discuss about the alternate hypothesis or research hypothesis. An alternate hypothesis or a research hypothesis. Null hypothesis assumes there is no difference exists between the two groups or samples. Okay, in alternate hypothesis or HA is the hypothesis which assumes there is no significant difference between the two groups. Okay, here HA or alternate hypothesis can be written as mu1 not is equal to mu2, where mu1 and mu2 are two different groups under study. Okay, so it assumes there is no significant difference between the two groups. Okay, whereas alternate hypothesis or HA assumes there is a difference, they are not equal. Okay, what null hypothesis assumes there is no difference, that means mu1 is equal to mu2. Okay, where mu1 and mu2 are different groups. Okay, alternate hypothesis assumes there is no difference, there is a difference, that means they are not equal. Okay, therefore mu1 not is equal to mu2. Okay, in common practice this alternate hypothesis can also be regarded as research hypothesis. Okay, to minimize the chance variation, or to minimize the values of errors, we set particular limits. Okay, and the idea which originates from this is the level of significance. Okay, the significance level or level of significance can be written as alpha, and it is the probability of rejecting the null hypothesis when it is true. Okay, the probability of rejecting the null hypothesis when it is true should be low. Okay, because if the null hypothesis is true and if we reject the null hypothesis, and that will be regarded as an error. Okay, so when the null hypothesis is true, that means if there is no really a significant difference between two populations, but we are still accepting the if we are still rejecting the null hypothesis, okay, that results in the type 1 error or alpha, and this is also termed as the significance level or level of significance. For example, a significance level of 0.05 indicates a 5% risk of concluding that a difference exists when there is no actual difference. Okay, so up to 5% we can allow this kind of error. Okay, therefore the level of significance is less than should be less than 5%. Okay, or the alpha value should be more commonly it will be set at 0.05, but we can also set like 0.01 or 0.02, 3 or 4, any value that is less than 0.05. So the significance level determines how far how far out from the null hypothesis value, and we can draw this, or we can represent, or for better understanding we can represent in a graph that we'll see in the coming slides. So for better understanding of the level of significance, if we plot the normal distribution, okay, and this region is termed as critical region, that is the region in which there is a 5% error or allowable error, or the level of significance or alpha value which we have discussed previously is there. Okay, this is the critical region. If your mean values of a particular population falls under this critical region, okay, you should you should not reject the null hypothesis. Okay, if your mean values fall in the critical regions, you should not reject the null hypothesis. Okay, and your mean values always should be far from the critical region. Okay, so here in this example, in a two-tailed test, okay, the sample means fall under the critical region, whereas in that there is no the sample means do not fall under the critical region. Okay, so here you will reject the null hypothesis, but here you will not reject the null hypothesis. And then what is the p-value? The level of statistical significance is often regarded as p-value. Okay, and the value of p lies between 0 and 1. The smaller the p-value, the stronger the evidence that you should reject the null hypothesis. Okay, again in the graphical terms, the area that is less than the alpha value, or that is far from the critical region, okay, or the value which is less than alpha is your p-value. Okay, so if the value which is less than alpha, or if the p-value is less than the alpha value, okay, which means which is the border for a critical region, you should you can tell there is a significant difference and we can reject the null hypothesis. Okay, and if it is not falls under the critical region, or if the p-value is greater than alpha, you can say that there is no significant difference between the two groups. Okay, so this is the rejection criteria or acceptance criteria for the significant difference. So a p-value less than 0.05, typically less than or equal to 0.05, is statistically significant, and it indicates strong evidence against the null hypothesis, as there is less than 5% probability the null is correct. Okay, and the results are if the results are random, and therefore we reject the null hypothesis and accept an alternate hypothesis when the p-value is less than 0.05, or if it is less than or equal to 0.05, we will reject the null hypothesis and accept the alternate hypothesis. However, if the p-value is below the threshold of significance, that is p less than 0.05, you can reject the null hypothesis, but this does not mean that there is a 95% probability that the alternate hypothesis is true. The p-value is a conditional upon the null hypothesis that is being true, but it is unrelated to the truth or falsity of the alternate hypothesis. That means when the null hypothesis is below 0.05, we can reject the null hypothesis, okay, but it does not mean but it does not always mean that we should not accept we should accept the alternate hypothesis under study. A p-value higher than 0.05 is not statistically significant, and it indicates stronger evidence for the null hypothesis, and this means we retain the null hypothesis and reject the alternate hypothesis. Okay, so if our p-value is greater than the 0.05, then we can we cannot reject the null hypothesis, and we cannot accept the alternate hypothesis. For example, if the p-value is greater than 0.05, it is regarded as not significant. Okay, if the p-value is less than 0.05 or equal to 0.05, it is termed as a significant difference, and if it is still less than 0.01, it is regarded as very significant, and if it is less than 0.001, it is termed as highly significant. Okay, so this is the table we need to remember while we are assigning the significance. And the power of a study. The power of an hypothesis, or the power of a test, or a power of an hypothesis test, is the measure of how effectively the test is at identifying a difference in a population. Okay, how effectively, that means how effectively without an error we are measuring the statistical significance is termed as a power of a study. The power of an hypothesis test is the measure of how effectively the test is at identifying a difference in a population. If such a difference exists, if such a difference is really existing, how effectively we are measuring that particular difference is termed as statistical power of a study. It is the probability of rejecting the null hypothesis when it is false. Okay, the probability of rejecting the null hypothesis when it is true is termed as alpha, or level of significance, and the probability of rejecting the null hypothesis when it is false is termed as beta, that is the power of a study. Okay, so here in this table you can see the type 1 error can be regarded as alpha, and the type 2 error is regarded as beta, or the power of a study. There are two possible errors, as we discussed now, associated with the hypothesis testing. The type 1 error or alpha is the probability of rejecting the null hypothesis when it is true, and the type 2 error, which is the probability of rejecting the null hypothesis when it is false. The level of significance can be termed as alpha, can be a type 1 error, and the power of a study is a type 2 error, and it is symbolized by the Greek letter beta. So the level of significance can be written as, or the type 1 error can be written as 1 minus alpha, and the type 2 error is or written as 1 minus beta. Type 1 error is also called a false positive result, and the type 2 error is also regarded as false negative result. And coming to the confidence interval. A confidence interval displays the probability that a parametric or a test, or it displays the probability that a parameter will fall between a pair of values around the mean. Confidence intervals measure the degree of uncertainty or certainty in a sampling method. Okay, we use the confidence interval to determine the degree of uncertainty or certainty in the sampling method we use, or to increase the power of a study. And they are most often constructed using confidence intervals between 95% and 99%. Okay, and even if you see the normal distribution, and the confidence interval falls between 90 and 99%. Okay, in order to determine the confidence interval, first we need to know the standard error. Okay, and at 90% confidence interval, the standard error is minus 1.65, and at the 95% confidence interval, the standard error is minus 1.96, and at the 99% confidence interval, it is minus 2.58 when it falls under the left side of the two-tailed curve, and the same is the right side, but we'll get a positive values. Okay, from this we can say that at 95% confidence interval, the population mean is equal to the sample mean plus or minus 1.96 into standard error. Okay, so before seeing the example of calculating the confidence interval, we need to be clear with the confidence interval. At 95% confidence interval, the sample mean is minus 1.96 into standard error to the sample mean plus 1.96 into standard error will include the population mean. Okay, and in probability terms, there is a probability of 0.95, the interval from the sample mean minus 1.96 into standard error to the sample mean plus 1.96 into standard error. Okay, in this graph we can see the values at 95% confidence interval, for example minus 1.96 to plus 1.96 into standard error mean. In other words, if we can pick one out of all the possible sample means at random, there is the probability of 0.95 that will lie within two standard errors of population mean. We call the distance from the sample mean minus 1.96 into standard error mean to the sample mean 1.96 into standard error mean of standard error mean, or you can regard it as x bar. Okay, let us see the formula for calculating the confidence interval. The confidence interval, the p%, can be calculated by using the formula x bar, that is the mean, plus or minus z1 minus alpha by 2, that is the value which corresponds to the particular the confidence interval what we are using from the graph. For example, for 95% confidence interval, this value would be 1.96. okay, and that won't change, and the sigma is the standard deviation, and the n is the number of samples or the sample size. So the confidence interval can be regarded as mean plus or minus z1 minus alpha by 2 into sigma by square root of n. Let us see an example. In a clinical study, a new anticoagulant drug has been performed in 30 patients, in which the volume of distribution was found to be 10.2 plus or minus 1.91. Now, how to calculate the 95% confidence interval of this mean value, that is the volume of the mean volume of distribution is 10.2, and we have to calculate the 95% confidence interval. Using this, according to this formula, the mean value were given. Was given, and Z1 minus alpha by 2 will be the 1.96, as they are asking us to calculate the 95% confidence interval. Z1 minus alpha by 2 value will be 1.96. okay, and similarly after the value after plus or minus it will be the standard deviation, that is the sigma value. Okay, here they have performed this study in 30 individuals or 30 patients, therefore the sample size of this study would be 30. okay, so here the mean value x bar is 10.2, Z1 minus alpha by 2 is 1.96, and sigma value is 1.91, and n, or the number of observations, is 30. So now you have to calculate 95% confidence interval, that is we can write it as P95%. okay, the P95%, the x bar value is 10.2 plus or minus Z1 minus alpha by 2 value will be 1.96 by default, because we are asked to calculate the 95% confidence interval, into the standard deviation value is 1.91 divided by square root of 30, and this will give you the value of confidence interval that is 0.68. okay, so it can be written in terms of mean plus or minus confidence interval, therefore the mean value won't change, 10.2, so 10.2 plus or minus 0.68. The 95% confidence interval was found to be 10.2 plus or minus 0.68 liters, that is 9.52 to 10.88 liters. okay, so this is the example, or how to calculate the confidence interval. In the next class we will discuss about the non-parametric and parametric tests, and how to select the which tests for hypothesis testing, and what is a parametric test and what is a non-parametric test. Thank you.